In this video, I'm going to show you how to do simple linear regression in SPSS. So regression builds off of correlation in that it deals with the degree of relationship between two variables, but it goes one step further in allowing us to predict the value of one variable if we know another. But the accuracy of the prediction will depend on the strength of the correlation between those two variables. I cover some of the conceptual background of regression in a video I made showing you how to do regression in Excel, so you may want to take a look at that for some of the background. And I'm going to use the same example here of trying to predict a person's IQ score if we know how much caffeine they consumed. Now I hope it goes without saying that my example is totally made up. These data are made up, so don't start drinking a ton of coffee and expect your IQ to change very much. So basically, if there's a relationship between two variables like these, we can use the value of one variable to predict the value of another. So whatever variable we're using to predict something else would be the x variable, and whatever variable we're trying to predict would be the y variable. So in this case, we'll pretend that we're using caffeine consumption to predict a person's IQ score. Now ultimately, we're going to end up with a regression equation structured like this: y equals bx plus a. In this formula, y is the value of the variable we're predicting, and b is the slope of the line, which we multiply by x, the value of the variable we already know, and a is the y-intercept, the point at which the line crosses the y-axis when x equals 0. So before we construct anything like this equation in this format and start predicting people's IQ scores, we need some data. We need to see previous instances of how caffeine consumption relates to IQ scores. And these are the data on that. So we see various people's daily caffeine consumption and those same people's IQ scores. So we can use these data to construct the regression equation, then predict the IQ scores for other people whose IQs we don't actually know. The only thing we do know about them is how much caffeine they consumed. So once you have these data popped in, it's pretty easy to run the regression in SPSS. You just need to go to Analyze, and then Regression. Now, there are many different kinds of regression. The one we choose depends on what kind of relationship exists between the two variables. It can be straight, it can be curved, or U-shaped in some way. We don't actually know for sure what kind of relationship exists, so it might be a good idea to graph it first and take a look. So there are a couple of different ways to create graphs in SPSS, and I'm honestly not the biggest fan of SPSS's graphing capabilities, but let's take a stab at it anyway. The menu is right up here under Graph. I prefer going to Legacy Dialogues and then just picking the kind of graph you want, which would be a scatter plot. There are different kinds. I like to go with simple scatter. Hit Define. Now here, you just have to move over the variables into either y or x-axis. Now remember, the variable you're trying to predict is the y variable, so we're trying to predict IQ scores, and the variable you're using to predict is the x variable, so that'd be caffeine dose. Once you have those things popped in there in the right order, click OK, and this graph will pop up. There you can get the exact same result if you go to Graph and Chart Builder. I don't really like this because I find it a bit confusing, but you get the same result. You pick what kind of graph you want, a scatter dot, and then whichever one of these kinds visually whichever kind of these graphs that are visually depicted you like, just click and hold and drag it up here, and then just drag your variables over. So I want caffeine dose to be on the x-axis. I want IQ score to be on the y-axis. Once you have it, this is just an example of what it looks like, or what it might look like. Click OK, and you get a very similar looking graph. So two different ways to get basically the same thing. Either way you do it, you can kind of get the sense that the relationship is roughly a straight line. So I think a linear regression would be the most appropriate type of analysis to do. So you go to Analyze, Regression, we'll pick linear, and in pretty much the same way you did the graphs, you just move over the variables in the same way. Caffeine dose is going to be your independent variable, the thing you're using to predict, and IQ score is the dependent variable, the thing you're actually predicting. And once you're ready, you can just click OK. Now, as usual with SPSS, we get a lot more than we really need. This first table can pretty much be ignored. There's really nothing useful there. The second one, model summary, does have some useful things. R. R is the correlation coefficient between the two variables. It's about 0.92, which is a very strong positive correlation, which we could have guessed from the graphs. It's very tightly clustered and moving from the bottom left to the upper right, so that's a positive correlation. We also have R square, which is exactly what it sounds like. It's the square of R, or 0.917 times 0.917. Another name for this is the coefficient of determination. So whatever you call it, it can be used as an indication of how good your regression equation fits your data. It's the proportion of variance in your y variable that you can explain with the x variable, but generally numbers closer to 1 indicate a better fit. So just keep that in mind. You can ignore adjusted r squared for now, but you can take a peek at this thing called the standard error of the estimate. This is a measure of variability, kind of like the standard deviation, which we've dealt with before. This tells you how much inaccuracy you're going to get from your predictions. And for now, all you really need to know is that smaller numbers mean more accuracy, and larger numbers mean less accuracy. This ANOVA table can be useful, but I'm not going to focus on it here. Instead, I just want to show you where you can go to get the information you need to construct your regression equation. And it's right here in the coefficients table under unstandardized coefficients. This thing called constant, that's your y-intercept. This is the supposed or the predicted IQ score of a person who gets 0 caffeine. And the thing right below it is the slope. So for every additional milligram of caffeine a person consumes, this is how much their IQ scores increases in this example. So you can put these values here into your IQ score, or into your regression equation structured like this, and you can start calculating for y and making some predictions. Now, needless to say, there's a lot more you can do in SPSS with regression. All these wonderful things here. You can do multiple linear regression where you have several predictor variables. You can even do non-linear regression too. But the stuff we just did with simple linear regression should get you started.